Good afternoon, everyone. I'm Mauricio. Although I'm listed here as a senior principal engineer, I recently moved to a lead architect position, so this is already a bit outdated. But anyway, let's get going. Today I'm going to be talking about how Pismo approached the challenges of creating a cutting-edge cloud-native banking systems. Of course, leveraging the resources and all the features we have available at AWS. So. Anyway, I'll just give you a quick overview. There are too many slides here. I'll try and get to and cover most of the topics here. And then I'll invite everyone, if you want to learn more about what I'll be talking here, to please join our booth there. It's just a few steps away from here. So you're all invited to join us there and be happy to take you through the rest of the slides there. Now, anyway, what is Pismo anyway? Well, Pismo is a payment processing platform, cloud native. We have a very comprehensive set of features that goes from a card issuing and card processing to account management and managing all the life cycle of those accounts, ledger management, and so on. And as I said, we're a cloud native company. We have features like multi-hierarchy, multi-region, multi-country. You can build your own organizational structure in Pismo with different parameters and configurations for each of those hierarchies and so on. It's a self-service platform, so basically you build your own products there and you have ownership of your own products there. You don't need to rely on us to build those products for you. And to talk a bit about our numbers, our performance numbers, just to give you a sense of the size of Pismo and our businesses. We see on average over 10 billion API calls per month. That's a lot of API calls. We have an uptime of over 49%, almost 59%, 99.997% of uptime. And on average, we have about 24 milliseconds of latency if you count all the applications. We're microservices based, so if you count all the applications, on average, we have a latency of about 25 milliseconds. And we see our clients using in production and reaching about 4,000 TPS in product. These are nominal volumes. This is not how much the platform can reach to. It's if you look at load tests, we can get much more than this. But this is essentially what our clients using for now. And in terms of financial volumes, we process or goes through the platform over $18 billion per month. Goes through our platform. Now, what are the challenges involved in building this kind of platform in a cloud-native fashion and hosting it in a cloud environment? Well, there's a lot of challenges to this, like security. You have to be compliant to various regulations. We have to have lots of several certifications. We have to guarantee integrity. $1 in, $1 out. Some industries, like you say, if you take video streaming companies, they can lose one or two pixels along the way, but we cannot afford to lose a few cents or dollars along the way. We have to guarantee integrity end to end. Also, we have a global presence, so we have clients spread all over the world. We have essentially here in the United States and Brazil, Chile, Europe, UK, Australia, India, Singapore, and all of those places we have to meet local requirements, comply with some local regulations, and connect to local service providers or payment rails and so on. We have to ensure resilience, continuity of business. Our clients rely on us to move their financial transactions around and process those transactions. And in a way that it doesn't hurt their systems. And anyway, that they're counting on us to run critical service for them. In terms of performance also, as soon as we start scaling, we may see degradation in performance, so we have to be very sure we're not impacting performance as we scale. So performance is also a thing that we need to be careful. And cost effectiveness also, cost can have a huge impact while you scaling your services. So you can quickly get out of control if you don't have a close look at how you're managing your costs. So if you take a look at these challenges, they pretty much are covered by well-architected pillars. And these are all best practices. If you don't practice well architecture, you should be doing this. And we do this in a recurrent way. We do recurrent well-architected assessments on our systems and so on. So we can guarantee at least the best practices and build a foundation, a solid foundation in which we can build our services. Now, there's another, when we talk about building this solid foundation, this is kind of like the bare minimum you have to build your platform on. Now, we can go one step further in each of those challenges. For instance, like if we take like modular services, it's a best practice to build your service as modular as possible. So you can leverage things like microservices patterns. You can use EKS, and we certainly do use EKS a lot. Leverage things like service mesh. But if you want to go one step further, having modular service is not enough. We can think a bit far away and think about composable services. They're not only modular, but composable. Think about building application tiers, like you have orchestration layers, you have service provider layers, you have core layers, and so on. So you can have different tiers of applications, and all of those can work in tandem. So you can mix and match different parts of the platform and compose different services and compose different features out of those services. And for this, we leverage things like event-driven patterns. So this is kind of like the foundation of our services. We use event-driven patterns all over the place in Pismo. And essentially what it does is, whenever we have any state change to the platform, we signal this state change with an event. So we emit an event internally, and this event can be consumed by different other offline services. Like for instance, if you take here a very simplified account opening service, which is managed by this acquisitions API thing here. Whenever a new account is created, we emit an event because there's a state change to the platform. So we emit an event, and there's another service that captures this event and further process this information. But we can build something on top of it. We can have other services that could benefit from this, also from listening to this event being emitted. Like for instance, the Ledger API needs to bootstrap that account and its record. So it listens also to this event and build some offline services. But we can keep building and stacking new different services, and all of these are completely decoupled. So we don't have to update or change or interfere in any way with this main workflow here. I mean, we can keep plugging new functionality and extending the functionality of the platform by listening to those state change events in the platform. Another way is maybe working with gateway patterns. Gateway patterns is, well, I have one, in this case here, I have an anti-fraud system. Pismo doesn't provide an anti-fraud service. We don't provide that ourselves. We rely on third-party partners for this. But we also have this policy so that clients can bring their own anti-fraud providers. And how we connect these providers is by building just the adapters to these providers. They're all providing anti-fraud services. What we need, the output I need from those providers are simply is a fraud or is this transaction not a fraud, and take a decision based on that. So I can have one gateway, which is represented here by this anti-fraud API here. So it can keep one single interface that is common to all the platforms. So I can reuse this component and use the same principle of mixing and matching different parts of the platform without interfering with the main part of the main flow of this particular application here. And if some clients come up with a different anti-fraud provider, that's easy. We just build a different adapter for that new provider that just came in. And the interface remains the same. Now, in terms of how our clients connect to our systems, we have a standard menu of connectivity options. And this is best practice also. Like we offer secure, zero trust, MTLS-based connection. We leverage edge locations. And there are also all the components that are highly available and multi-AZ by default. But can we go one step further? Well, instead of just having standard connectivity, what about we have adaptable connectivity? Like we still have some standard options, but they're based on parameters that I can tweak and build new types of connectivities. And by this, we leverage infrastructure as code. 100% of our infrastructure is expressed by code. They have their own repositories and so on. We can leverage code best practices like having modules, having interfaces to communicate different parts of the infrastructure as code. And with that, we can build things like single or multi-region environments, single or multi-tenant environment. Our clients can choose whatever region they want to run. And all of this is, these are parameters in our infrastructure as code. So just to give you an example here, this is one simple environment in which we're connecting through the internet with MTLS validations on the way, and it's a single region environment. But we can also have the same environment, but with a private link connectivity. If the clients are, these clients are running on AWS and they want private connectivity, these are just parameters we use to build different environment and different scenarios to adapt to different clients' needs. Same thing with multi-region. We can have like a DR region. These are the same environment, but if we tweak some parameters there, we spin up a multi-region environment, also with connecting through the internet. But it's also possible to do the same thing and use the same infrastructure as code to have multi-region with private link also. So we can tweak those parameters and build completely different environments based on our clients' needs and come up with different environments altogether. Okay. Now, if we look at real-time notifications, also there's a best practice to inform your clients that something happens in the platform that they might be interested in. So we have real-time notifications also. We support push and pull models, so we push these events and these notifications into our client's infrastructure, directly to their infrastructure. But we also have an S3 bucket, so they can come up and pull the event as required. Those are a fast delivery. These are near real-time with very fast SLAs, and support most cloud message brokers, and then we expand to other ones. But instead of just real-time notifications, what about having real-time event delivery? And what I mean with event delivery is leveraging that event-driven system that I showed you in a few slides back. And if you remember well, we had those events that represent state change to the platform, and we leverage those events to build and extend the functionality of the platform. What about if we provide our clients with this very same event so they can do the same thing on their side? So these are not just notifications. They get the full event with the same information we use internally to build their own orchestrations and build new features out of the platform. So this is what it looks like. So we have what we call a data platform. So we have event producers. That's our cluster, our services producing events that is captured by a data platform that puts this, does some schema validations and other validations. It separates those events by client, by tenant, and we fan out those events to our clients. And of course, we here we support both fanning out, and the pool model. So we have also the S3 bucket for our clients to come in and get those events also. Now, what about microservices? Well, of course, we are a microservices-based platform also. We run on EKS clusters. So they're very good for scaling horizontally. They're very fast to scale compared to full-fledged virtual machines. We build, of course, for microservices, we build stateless applications. We have end-to-end monitoring and synthetic testing baked in with using Istio and all of those service mesh facilities. Now, what about going one step further and not having just microservices to guarantee availability, but what about having self-healing applications? Applications that push the state of the platform into a consistent state. Now for that we have ephemeral design. Our applications are meant to be destroyed. They are meant to be stopped at any time. So we have graceful shutdown baked in those applications as well. And we have what we call integrity queues or integrity messages. It's an internal mechanism that we have that keeps constantly compares a desired state with the current state and push the state of the platform into this desired state. So we may roll back things that shouldn't be created in the first place, or we probably roll forward things to finish creating what should be created, but somehow got missed along the way. And of course, all of that, for having all of that, we do need some very strong guardrails around that. So we have a very strong security team involved in guarantee that everything that, all those things that we build are built in the with a very strong security posture. We have also a very comprehensive CI/CD framework that is fully automated. Also part of our infrastructure as code, so the CI/CD itself, it's expressed in code, and we have an extensive monitoring over to guarantee that everything runs smoothly in this kind of framework. We have over 2,000 alarms in the platform. Not all of them are critical alarms, but we have 2,000 alarms in this throughout the platform. So we know what thing is happening when things start to get getting wrong and getting bad, so we can preemptively act on it. And of course, as I said, infrastructure as code is paramount for this. We do have 100% of our infrastructure expressed as code here. So this is a few of the numbers we have on this. So we have, with all of this, we can reach to 100 releases per week. So it's a very intense CI and CD pipeline. We have less than 15% of change failure rate. We're running about 13 to 14% of change failure rate. That is bugs that are created in the platform. And when we go down 15%, if you take DORA metrics, we're already operating on an elite DevOps performance level. And of course, as I said, 100% of infrastructure as code, so all of our infrastructure is expressed as code, and we have extensive monitoring. As I said, we have over 2,000 alarms. Now, I have a few more slides here that I won't have enough time to go through it. I invite you all to walk to our booth. It's just a few steps here away from here, as I said. You're welcome to check it out there. I can finish presenting there if you want to, and I can answer some burning questions you might have as well. Okay. Oh. That's it. Thank you very much. Thank you for showing up. Coming up.